Welcome to Steady Life. In this session of kinetic theory of gases, we are going to talk about Charles' law. Again, this is a gas law, therefore, it is only applicable for gases. Basically, this law was created in the year 1783, almost 100 years after Boyle's law was derived. Charles' law basically focused on the ideas of volume and temperature. He observed that if I decided to increase my value of temperature, I'll also observe that the volume increases, the volume of the gas increases. This is very clear. This very clearly says that if we decide to increase the temperature, the volume is going to increase. If I decide to decrease the temperature, the volume of the gas is also bided to decrease. This is a very simple idea. Let's just work over here. V is directly proportional to T can be expressed as V is equal to KT. Assuming that K is nothing but just a proportionality constant with nothing extra definitions attached to it. This is a very simple idea. You just have to increase the temperature of the gas, the volume of the gas increases. This is the idea. But what is the volume of a gas at any specific temperature T? If you are asked to calculate the volume of a gas at any specific temperature, let's say T. So this is expressed as V naught. That is the volume of a gas at 0 degrees plus V naught times T. What is T? The temperature of the gas divided by 273.15. This is your 0 kelvins. 0 degrees centigrades, right? So what am I supposed to do? I'm supposed to take V0 common. All you have is 1 plus T upon 273.15. When solving for entrance examinations, you basically can make this as 273 and solve it. There's no need of using your decimals with it. Okay, let's start. Let's again focus on this equation. V is directly proportional to T. If I work on this and I decide to change my value of temperature, my value of volume also changes, thereby giving me a value V1 by T1. I also create a different temperature and a different volume. I also change the temperature, again my volume changes, and it is observed that all of these ratios are constant. All these ratios are constant. In here, something that is very important is to keep my value of pressure as constant. I should not be changing my value of pressure. My value of pressure never changes. Make sure you always remember this. My value of pressure never changes. Also, my gas, the number of molecules in my gas also doesn't change. I also assume that N, the number of molecules in my gas, also is constant. That is also something that should not be changing. If I decide on to draw a graph between V and T, this is what it looks like. There's a volume over here on the y-axis and a temperature on the x-axis. I observe that in here, my graph is a plain straight line with a positive slope, stating that it is in direct proportion. I am supposed to increase the temperature and the volume goes up. So I assume it's very clear. And this is the idea for an ideal gas. It's generally observed that even for real gases, this is how it works. But yes, this is observed only when my temperature is higher. When my temperature is high, my ideal gas are bound to behave like real gases. And this is what the graph looks like. Very simple, very basic, very easy. In our next session, we are going to talk about Avogadro's law. So suppose I'll see you all with Avogadro's law and me on Study Live. Until then, keep learning. Thank you.